Welcome back. Let's talk about gas exchanges and control of ventilation. So, gas exchange is known as respiration, and there are two sites in the body where gas exchange occurs. And those two sites are called external respiration and internal respiration. And please do not fall into the trap that a lot of students do, which is they think external respiration is an exchange of air between the outside and the lungs. That is not a gas exchange. That is not external respiration. That has nothing to do with this topic. Okay. So, external respiration occurs in the lung, yes, but it's an exchange of gas between the gas in the air and the blood in the pulmonary capillaries. So, do you remember that respiratory membrane we talked about previously? That's where external respiration occurs. So, we are going to be sending oxygen from the alveoli across the respiratory membrane, and it's going to bind with the iron in the middle of the heme of hemoglobin, forming oxyhemoglobin or hemoglobin O2. And we are going to be sending carbon dioxide, most of which is found in the plasma as the bicarbonate ion. So it gets bound back with the hydrogen ion to reform carbonic acid and then separates again into water and carbon dioxide. And then the carbon dioxide is unloaded as a gas into the alveoli, and then we exhale the gas of carbon dioxide. So that's external respiration. It occurs across the respiratory membrane between the pulmonary capillary and the alveolus. Now, internal respiration occurs at the tissue level. And so it's going to be exchange of gases between blood in the systemic capillary and the tissue cells themselves. So here we have a systemic capillary that has oxygenated red blood cell. It's going to unload the oxygen so that the cell will have oxygen so the cell can do cellular respiration. And so the red blood cell, each hemoglobin will unload one oxygen, so it'll still have three on its first pass. And so if it needs to come around a second time, it can unload more. And then it's going to deal with carbon dioxide. It's going to pick up carbon dioxide from the tissue. So remember, 7% of carbon dioxide is going to be dissolved as a gas in plasma. 23% of carbon dioxide is going to be bound to hemoglobin directly. And then 70% of carbon dioxide is going to react with water to form carbonic acid, which will then dissociate into a hydrogen ion and a carbonic acid. And then as part of the buffer thing, the hydrogen ions will bind with hemoglobin to maintain our pH. Remember, our pH is in a very narrow range on the basic side between 7.35 and 7.45. We are not neutral. Our body does not like to have a neutral blood pH. Likes to be slightly alkaline, 7.35 to 7.45. So those are the two sides of internal respiration. So we chemically can control this with ventilation by changing our rate of ventilation. When we change our rate of ventilation, we can breathe faster to blow off more CO2, or we can change our depth of respiration to blow off more CO2, or we can breathe shallower to blow off less CO2, or to, I guess I want the previous slide, or to breathe slower to blow off less CO2. So we can change depth or rate of respiration to change how much CO2 we are blowing off. And that will affect this equation because it affects how much CO2 is available to bond with water to form the carbonic acid to break up into a bicarbonate ion and a hydrogen ion. So we have central chemoreceptors in our medulla oblongata and in our pons. I'll talk about on the next slide. But then we have peripheral chemoreceptors, which are monitoring this. And here we see them in what's called the aortic bodies, which are on the arch of the aorta, and our carotid bodies, which are where our common carotid arteries are bifurcating right here by the angle of your mandible, where they bifurcate at what's called the carotid sinus, where the common carotid artery is bifurcating into the internal and external carotid arteries. And so from the aortic arch, we have the vagus nerve sending information to the brainstem, and from the carotid arteries, we have the glossopharyngeal nerve. So both of these cranial nerves are sending information to our brainstem. And basically, notice the information is not monitoring oxygen levels. Okay, everybody thinks breathing rates are based on oxygen levels, but they're not. It's monitoring carbon dioxide levels, but it's monitoring indirectly by looking at your pH, which has to do with your hydrogen ion levels. Okay, so pH has to do with hydrogen ion, which has to do with carbon dioxide, not oxygen. Okay. And so breathing has to do with this part of the equation, which is going to directly affect your hydrogen ion concentration. So how are the central chemoreceptors going to respond to this? Well, we have respiratory control centers in our brainstem. We've got 3 of them in our medulla and 1 in our pons that are monitoring these peripheral chemoreceptors, as well as we have receptors like in our limbic system when we get very emotional, which are going to affect these. So let me show you these respiratory control centers. So here's a picture of your brainstem. Here's the pregnant belly that you associate with the pons. So this is the medulla oblongata down there. So the first center I want to talk about is this one right here. It's on the posterior aspect of the medulla oblongata. It's called the dorsal respiratory group, and it's an inspiratory center. In other words, it stimulates inhalation muscles. Specifically, messages from here are going to go down respiratory pathways in our spinal cord, and it's going to stimulate the diaphragm and our intercostal rib muscles, which are going to elevate our ribs for passive inhalation. So the dorsal respiratory group has to do with passive inhalation. And a lack of signals from here is what triggers passive exhalation, because as we learned before, passive exhalation has to do with relaxation of the muscles of passive inhalation. So contraction of those muscles gives us passive inhalation, relaxation gives us passive exhalation. All right, now just in front of those muscles, so anterior to it, we have what's known as the ventral respiratory group. And this group has nerves which are going to stimulate muscles of forced exhalation. If you remember, we had more intercostal muscles which would depress your ribs more, as well as contract abdominal muscles. So it would make your thoracic cage even smaller for forced exhalation. Now, just above the ventral respiratory group, we have this group called the apneutic center. To understand that, you have to know that the word apneusis means lack of breathing, like when you're holding your breath. Okay. So the apneutic center recognizes when no breathing has happened for a certain period of time. So if you go 20 seconds without holding your breath, this is going to adjust your respiratory rate by sending an impulse to the dorsal respiratory group, which, as we learned before, stimulates your muscles of inhalation, thereby forcing you to take a breath. And then the last group is not in the medulla oblongata, but it's much higher. It's up here in the pons. And so it is known as the pneumotaxic center, although some people call it the pontine respiratory center because it's in the pons. And what it does is it adjusts the depth and the rate of respiration regarding your activity. Because yes, if we're exercising, we breathe faster and we breathe deeper, but we don't want to blow out our lungs. So remember, if you're blowing up a balloon, you can keep on blowing and blowing and blowing until it pops. But when we're inhaling, we don't want to keep on inhaling until we blow out our alveoli. So this prevents inhalation to prevent the overinflation to pop our alveoli. So why do I want you to learn this? Why is this important? So let me give you an example. So let's just say sometime you're standing in line or Target at the grocery store, and not you or anybody you know, but somebody is there with a child who is misbehaving and is yelling at their parent because they want something that's being sold at that checkout line. And they're saying, like, Mommy, if you don't buy this, I'm going to hold my breath and I'm going to turn blue and I'm going to die and you're going to be sorry. And you're going to remember, oh, we have that apneutic center that will recognize when no breathing happens and will force you to take a breath. So you will think to yourself, go ahead, it's not going to happen. And with that, we're done with this section. So come on back. I'm going to start talking about some lung diseases. So we're off to the more fun topics now. See you soon.